A furnace over on the right-hand side on the bottom. It's a forced air gas furnace, and above that we have an evaporator coil. So that's all located on the right side of the wall. On the left side of the wall, we have an outdoor air conditioning system referred to as an outdoor condensing unit. And then over at the top left, you see the refrigerant state. So there's a color guide for each of the states that the refrigerant goes through during the refrigeration cycle. The refrigerant enters the vapor compressor as a low pressure, low temperature vapor. This can also be referred to as a gas. It exits the vapor compressor as a high pressure, high temperature vapor refrigerant that is superheated. The refrigerant enters the discharge tube and it rejects heat and lowers in temperature. Then it travels into the condenser coil and it continues to reject heat and lower in temperature until it turns into the saturated state. The saturated state is where liquid and vapor both exist at the same time. It's going to continue to reject heat, but it's not going to lower in temperature. It's going to maintain the same temperature as it gives off its heat energy until it gives off enough heat energy until it turns into a complete liquid. Once it turns into a complete liquid, it's going to then continue to reject heat, but now it's going to lower in temperature, and the temperature decrease between where it turns into a complete liquid and where it exits the outdoor condenser through the liquid service valve, that's called the subcooling. The refrigerant exits the outdoor unit as a high pressure, high temperature subcooled liquid, continues through the liquid line service valve, and goes over to the filter dryer. The filter dryer's job is to store any water molecules in the system, but it's limited due to its size. This prevents the water from mixing with the refrigerant wheel, which would create alcohol and acids. It then exits the filter dryer as a high pressure, high temperature liquid refrigerant. The high pressure, high temperature liquid refrigerant then continues over to the metering device. In this case, it's a thermostatic expansion valve, which is also referred to as a TXV or TEV. So at the TXV, you have a high pressure, high temperature liquid refrigerant entering in, and then you have a low pressure, low temperature liquid exiting the TXV. Now, due to the size of the tubing in the evaporator coil, you're going to have the refrigerant's going to expand. So you're going to have an 80% liquid, 20% flash gas roughly exiting the TXV. So it's already going to be into the saturated state where liquid and vapor both exist at the same time. It's then going to start absorbing heat energy from within the building, from the air crossing the evaporator coil. So it's going to absorb more and more heat energy, but it's not going to increase in temperature. It's going to do that until it's absorbed so much heat energy that it can then turn into a complete vapor. And once it turns into a complete vapor, the refrigerant then starts to increase in temperature. This is called superheating. The temperature increase between where the refrigerant turns into a complete vapor and where it exits the evaporator coil is called the superheat. And you can see that the TXV is actually monitoring the superheat with that external equalization line and TXV bulb. So the TXV's job is actually to monitor and adjust the superheat across that evaporator coil. It can do this by adjusting the refrigerant flow going through the metering device. So now you have a low pressure, low temperature vapor refrigerant exiting the evaporator coil, and it continues through the large vapor line until it gets to the vapor service valve. Then the low pressure, low temperature superheated vapor re-enters the compressor and the refrigeration cycle starts all over. The temperature increase of the vapor refrigerant where it exits the saturated state in the evaporator coil until where it comes over to the vapor line service valve is called the total superheat. The total superheat is used to check the refrigerant charge of systems that have a fixed orifice as the metering device. Since this system has a TXV as the metering device, we would use the subcooling method in order to check the refrigerant charge. This is because the TXV actually controls the superheat. If you want to learn more about refrigerant charging, troubleshooting, and the procedures we use to prepare a system for